Hello and good evening, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCMP route course, and this evening's video tutorial is going to be on Discovery Activity 6, where we're going to be taking a look at EIGRP load balancing. So we know by default that EIGRP can do UCMP, or Equal Cost Multi-Pathing, and we're going to take a look in this activity as to how to do load balancing across unequal metric paths. So let's go ahead and jump in here. It wants us to verify connectivity on the HQ router, or from the HQ router, from the HQ router over to the branch router. So we're going to ping 192.168.0.1, and we've got full connectivity there. Let's say show IP route, and you can see that we have two equal cost paths currently. So we have, actually we don't want to print that. So we have two successor routes here, and actually I know why it tried to print. Let's see if we can get desk scribble up here. There we go. So we have two equal cost paths currently, and you can see that they are right here. So this is our successor route. The successor route. These are, these here are the successors, 172.16.2.2 and 1.2, and they're both out Ethernet 0.1 and Ethernet 0.0 respectively. So if we were to clear this and take a look at the diagram, we can see that the two equal cost paths are going to be out these two interfaces here, Ethernet 0.0 and Ethernet 0.1. Obviously this 1 megabit per second link, not as quick as the 4 megabit per second links, which are going to be chosen as the successors. Successors. Right, and that's what we see in our routing table right over here on the left hand side. Okay, so and it actually explains that, tells you that there are two equal cost paths for the destination, 192.168.0.0, again the successor route. So it's going to be load balanced across those two paths. So if we were to take a look at the EIGRP topology table on the HQ router and say show IP EIGRP topo for topology, we can see that there are two successor routes, right? And it actually tells us right there. It tells us the feasible distance of the successor routes. However, it also lists a third route right here. And when we take a look at the reported distance, again, this is the RD, the reported distance of this candidate right here, and we compare that to the feasible distance of the current successor, we can see that the feasible distance is currently 409,600. The reported distance of this candidate right here is 128,256. So the reported distance of the candidate is less than, strictly less than, the feasible distance of the current successor. And therefore, we meet the feasibility condition, and that means we are a feasible successor. So this guy right here is our feasible successor route. And so if we come back and take a look here, that should be what it's telling us. And yes, both routes are within it. By default, only equal cost load balancing is enabled. So again, even though we have this feasible successor here, we're only load balancing across equal cost. So here is the cost. Let's pull that line back. So here's the cost right here, 409,600, and it's equal between these two routes. Okay, so the next thing we're going to take a look at is unequal cost metric paths. So EIGRP can balance across equal cost paths or unequal cost paths, and the way we deal with the unequal cost paths is with the variance multiplier. And so it spells out for you here in these paragraphs that the default value for variance is 1, and you can go all the way up to a maximum of 128. And in fact, let's confirm that. So if I was on the HQ router here and I said show run, and actually let's just jump into global config here. So we'll say config T, and then do show run section EIGRP. Let's take a look here. So router EIGRP 1, and we know that we're doing I'm sorry, not equal cost. We know that we're doing autonomous system classic mode EIGRP configuration. So if I say variance question mark, you can see that the values range from 1, which is the default, up to 128. So now we're going to go ahead and implement unequal cost load balancing by defining the variance metric here. And so it's key to remember that when we define the variance, what we're saying is the cost over the path, or I'm sorry, the cost of the path over the serial link is 2,297,856. The best cost path is 409,000. So we need to define the variance value as at least 6 or higher if you wish to include the path over the serial link. Because remember, we need to make sure that whatever we multiply as the variance value, whatever we multiply the current feasible distance by, we need to make sure that the metric of the candidate to be part of unequal cost load balancing is less than what the result or the product of this mathematical operation is going to be. So when the variance is set to 6 or above, the cost of that path is lower than the best path cost multiplied by the variance. And so I actually have a pretty simple way to calculate this. So if I fire the calculator up here, this is really, in order to determine what the variance value should be, it's actually pretty straightforward. If I take 2297, and sorry about that, let's clear that out. So it's 2297, 856, and divide that by, and so again, this is the current metric for that serial link. It's right here, right? You can see it right there. And I'm going to divide that by the cost of the current successor. So we divide that by 409,600, and we get 5.61. And so again, all I have to do is divide the metric of the current feasible successor by the metric of the current successor. That's going to give me the value to which I'm going to want to set the variance. Now the key here is you can see it's 5.61. Well, this is going to have to be an integer, and I'm not going to be able to round up or down. So again, I can't put in 5.61 for my variance. So I need to make sure that I cover myself. So I would say 6. Right? Does that make sense? I hope. So again, you just simply divide the metric of the current feasible successor by the metric of the current successor, and that's going to give me the value that I need to put inside the variance argument, right, of the variance configuration, in order to ensure that I am less than. So if I were to clear that and say 409,600 multiplied by 6, I get 2.457 million. And when we compare that to the feasible successors metric, it is less, right? So 6 works out beautifully. And again, the easy way to calculate that is to simply take the metric of the current feasible successor and divide it by the metric of the current successor. And that's going to give you, and if you end up, like I said, if you end up with a fraction, you would simply round up, right? You're going to round up to make sure that whatever the product of that multiplication is less than, or is more than, the metric of the feasible successor. And that's a key. In order to do unequal cost load balancing, you can only do it with routes that meet the feasibility condition, because that's the only way to guarantee that you're going to be doing unequal cost load balancing over unequal cost links that are loop free. So again, there's a couple criteria. One, it has to be loop free, and two, it has to be a feasible successor. Well, in order to be a feasible successor, what's the condition? What's the feasibility condition state? Feasibility condition states that if the reported distance of the candidate is less than the feasible distance of the current successors, I meet the feasibility condition, because that is how I can guarantee loop freedom. Okay, so let's go ahead and clear that out there. And so we're going to take a look here, and we're going to go ahead and we're going to set the variance right now. So I said variance, and we'll say 6. And now when we say do show IP route, and we'll squeeze it down here, EIGRP, you can see that that's the only EIGRP learned route. But now how many routes are we load balancing across? Well, we've got 3, because now we have the serial interface. And you can clearly see here that the metric for the serial interface is nowhere near as good. In fact, we know it is 6 times worse than the current metric for the 2 successor routes here. So these are both our successors, and this is the feasible successor, who we are now, with the variance command, using to load balance traffic over. All right, so if I were to clear my screen here, and let's go ahead and say do show IP protocols, and we can see in the IP protocols output the maximum metric variance is set to 6. We have the maximum number of paths that we can load balance across, and we see the maximum hop count is 100 here. Now we can change this hop count to 255 if we needed to. We can also change the maximum paths. So let's actually go ahead and let's check with that. So if I were to say maximum paths and do a question mark, we could set it to 32. So I could do load balancing, either unequal or equal cost multipathing, across 32 paths, 32 different links to get to a single route. What if I were to set this to 2? What's going to happen? Because I set the maximum paths to 2, but how many are we load balancing over right now? We're load balancing over 3. Let's see how EIGRP, do show IP route EIGRP. Let's see what EIGRP does. And it appears that what EIGRP does is, even if we've set it to where we can have 3, it looks like the 2 that it's going to choose are going to be the current successors, right? So you can see the one that it decided to drop was the feasible successor. And so by saying max paths 2, we're only going to see 2 paths. If I clear this, and let's pull that command back up, what if I say 3? Then we get our feasible successor back, right? And so that's the maximum paths command, and that's how you can manipulate how many paths you're able to load balance across. Now this kind of ends up pretty short here. It just mentions maximum paths. Again, if we set it to 1, we're disabling multipathing. But let's take a look real quickly here at the do show IP EIGRP topology all links, and we can see in the all links output for that successor route, which is in the passive state, that the current successor route is 192.168.0.0. We have 3 successors. So it treats the third route as a successor. In other words, the one that has a terrible metric, which is this guy here, 172.16.3.2, over that 1 megabit per second WAN link, it still treats him as a successor. So what if we pull, let's pull that variance command off. So let's say no variance 6. And let's run that show IP EIGRP topology again. So when I remove the variance command, right, what do we see? So now it thinks there are only 2 successors, which are going to be these 2 guys right here. And again, it's all links, but if it wasn't all links, we still meet the feasibility condition. So that is our feasible successor, right? Okay, so really what's happening is when we run that variance command, It's actually sort of tricking the topology table into thinking that this route here meets the criteria to be a successor. So again, if I were to add it back in, variance 6, do show IP EIGRP topology all links, you can see that we have 3 successors, that it sees 3 successors now. And again, it's the variance command that allows us to do that. All right, so this was a really quick and short look at how to do load balancing across unequal cost paths. And again, what did we look at? Really, the variance command is what we looked at, but we need to make sure we have an understanding of the topology table, because at the end of the day, you can only use feasible successors to do unequal cost multipathing. So if I did the all links option and we had a 4th route here that didn't show up when I wasn't doing the all links option, we could not use that route to load balance over, because it doesn't meet the feasibility condition, which means we can't guarantee a loop-free path. All right, so again, that was just a real quick look at EIGRP load balancing. Again, another fantastic activity, that really isolates the concept of unequal cost multipathing and some of the commands that we can run in order to validate that we actually are doing unequal cost multipathing. All right, well, this wraps up Discovery Activity 6. I will see you guys all tomorrow night at 6 o'clock.